Hey guys, so this is the first video of week 1 in quarantine, learning physics via remote teaching. So I hope this video finds you guys well. Really wish we could do this face to face, but because of the circumstances, we are all staying safe at home. So we're going to do our best to get through this next few weeks, and hopefully these videos are helpful. My apologies if it seems shaky, but I have to actually hold my phone while I'm writing on the paper. So anyways, please make sure you read through the lesson before you follow these videos, because I may be going faster than you would want me to. So obviously you can pause it at any time and then rewind for those parts that you need re-clarification. So today's lesson is Newton's second law, but before we get into Newton's second law, I just wanted to remind ourselves what Newton's first law was, and that is done in the first section here. So Newton's first law is when the forces acting on a system are balanced, the object will remain at rest or moving at constant velocity. So that means mathematically that F net is 0, and remember that F net is the vector sum of the forces, meaning you add the forces in the directions that they're going according to your convention, positive and negative, and that's all equal to 0. So we're going to use this equation to solve a couple of initial problems here, and then move on to Newton's second law. Alright, so example A is an object sits at rest on a table. The force of gravity on the object is 25 newtons. What is the normal force? So we don't know what this thing is, we just know it's an object, so we're going to draw the interaction diagram. That's the object. It interacts with the table through a normal interaction, and then it has the gravitational interaction with the Earth. Okay, so that's it. From the force diagram, you're going to have your normal force upwards, because you're assuming it's sitting on a desk, and the gravitational force downwards, which is balanced, because this object is at rest. And our convention is the positive direction is up. Then it says write out the F net equation and solve for the unknown quantity. So basically what you do is you write F net equals, what are the forces? We got Fn and Fg, and Fn will be positive because it's up, Fg is negative, and then that is all equal to 0. So in order to find Fn, which is the normal force, which is what's been asked for, I'm going to just take this part of the equation and rearrange for Fn. So we have Fn equals Fg, which is equal to 25 newtons. Easy enough? So then you'd say the normal force is 25 newtons up, and we usually put our direction in square brackets. Alright, number B, or letter B, you're holding a ball that has a mass of 1.4 kilograms. Determine the force of gravity acting on the ball, and then determine the applied force you're imparting to the ball. That just means that you're applying to the ball. So we draw our interaction diagram as usual, the ball, and sitting in our hand, so it interacts with an applied interaction. And of course we have gravity. Nothing else. The hand is takes place of the normal force, so that we call that an applied force. Our force diagram is Fa up and Fg down, because our hand is supporting the ball and this thing's at rest, so my forces are balanced and my convention is up as positive. So it asks for the force of gravity first, and then it asks for the applied force. So force of gravity from last day is mass times g, which is 1.4 kilograms times 9.81 newtons per kilogram, which is, survey says, 13.7 newtons. And because of our two sig figs, that's going to go to 14 newtons. As for our applied force, we're going to write our F net equation. FA is up and FG is down, so we're going to go FA take away FG, and that's equal to 0 because that's Newton's first law. Plus this thing's not accelerating, but that's a bit of a spoiler alert. I'm going to rearrange the second part for FA so that I can find it, and I just set that equal to 14 newtons. And for FA, that's in the upward direction. I don't have enough room for a sentence, so I'm just going to leave it there. Okay, so the applied force that my hand is imparting to the ball is 14 newtons up.